Okay, we should be live. So welcome, Kuba. We are meeting at the, I think, 6th DevFlix meeting. Today we have Jakub Nabrdalik, who will be talking about his experience in building systems. So the meeting is scheduled for 1 hour, but I hope you will get as much as you could from Kuba, because his experience is probably a bit more than just 60 minutes. And to best utilize this time, ask as many questions as you want. Kuba has some kind of presentation to show, but it would be even better if you could ask questions. You will learn much more than just from presenting from Kuba. So we're gathering here. So if you are on the YouTube, you can join us at Ermit. So you should get the first link, viewer.pl/live, because here is much better experience in terms of interaction. So you can ask question and we'll hear immediately. In YouTube, you will have like 20-second delay. So it's better to join at Ermit. And before we start, I would like to thank Glovo. You may probably know Glovo. This is the company that delivers food for you, but they not only deliver food, but also like groceries and many more things. And they have offices around the world. One is in Warsaw. So I will start a very short 60 seconds video, and we'll prepare with Kuba, and Kuba will start the presentation after the sponsor break.
I said like, wow, this is the job I've been looking for.
There are no 2 days that are the same. Like, I'm always doing different things. Even though, we have job descriptions, there are always things that come up.
Glovo is growing so much, forces you to be on your toes always, to adapt very quickly, to change.
For me, it's important to work in a company that is really promoting and pushing sustainable and social impact projects.
It's been really amazing. Everybody, all my colleagues have been really helpful, getting me onboarded from the time I arrived. So yeah, I just love it here.
The people in Glovo are amazing. I can definitely feel that people really care about each other, but also like the company, and also the customers and riders and partners who are actually the inside of our ecosystem.
What I like the most about working here is that I have a voice, and I've been growing and learning since day one.
It's been amazing. I'm challenged every single day. I get to work with different cultures, with different people. I get to travel, which is amazing.
At Glovo, we welcome top performers from diverse backgrounds that bring in new ideas and perspectives.
Glovo will be the job of your life because you'll grow, have an impact, and work in a dynamic environment.
All right, Grzegorz. Grzegorz, I can't hear you. Hope others can. But
yeah, I told you to unmute and turn on camera, but I forgot myself. So yeah, the stage is yours, Kuba. So I will be in the background. I will be monitoring the questions and so on, and we'll try to interrupt you as frequently as I can whenever the question will show up. And you can ask questions in the Q&A or in the chat, or you can also raise a hand and you can join Kuba on stage if you are brave enough. So.
Yeah, so thank you very much. I can't do multitasking a lot, so please read Grzegorz, if you can, please read those questions when they arrive, because I won't be able to look at the chat and at the same time think about what I'm talking about and then show you anything interesting. So sorry for that. But I would prefer to actually have it interactive and basically be able to explain things. I even have my tablet with me in case we need to draw something instead of just showing the drawings that I had done before. So with all of that, let's just add. Let me see if I can actually share the screen if it works, right? Let's have a look. Because I got a presentation, of course. But as I said, it would be even better if we could just talk about cases. But oh well, let's start, right? So this is about, the architecture part that is interesting, especially to me in terms of my experience, because I got about 19 years of experience right now. But if you're here, you most likely can find out the more details about me or the company that I work for, so I'm going to skip that. The only important part is that, well, I kind of help companies in both moving to the public cloud and basically implement the architecture. And also what I do is I teach and I give a lot of workshops. And I'm talking about a lot of workshops, more than 150 right now, I think. So I talk with a lot of different architects, right? Now, and a lot of different developers. And basically what I see is quite a lot of them have the same problems as I do, which is why this talk is here, right? As I did, or basically I can help them by just showing them my mistakes or my errors. So this talk, everything I'm going to talk here about is not silver bullet or not true. It's not even ultimate truth, right? I'm not saying that this will work always in your situation. What I'm saying is it works for me. And from my perspective, working with, the things like telco, banking, fintech, e-commerce, and now power companies, or those things are basically, those things that I'm going to share, all of them actually work with me. And I'm just going to put my cat out. Just a second. Yeah. So they work for me. They might not work in your context. I'm not the only source of truth. Verify everything you hear and check whether it applies to your context. That's the thing I'm trying to say right now. Okay, so with all that ado, let's find out what are the things that I wished I knew years before, right? Now, the first thing is there is no such thing as a bad architecture or a good architecture. It's only bad or good if it doesn't meet a specific attribute that you want to achieve. And the question is, what do you want to achieve with a given design or architecture, right? Now, whenever I ask people and the developers and architects what they want to achieve, what does it mean for them? Like, what do you want in this architecture? They say something like performance, right? I want this to be very performant, or maybe to scale well. And the interesting part is that most of the time when we are looking at the kind of performance that we need right now, hey, this is 5 gigahertz machine. If you don't fuck it up, it's going to be fast enough, right? You got to do something really stupid to be able to slow down so much, like, for example, maybe lock on something, or maybe do the full table scan on a database, or anything like that, right? So as long as we don't make mistakes, it's okay. And for most applications, okay is fast enough. You don't have to be much faster than that. And here's the proof. This is Doom running on a CPU from 1975. Okay, it's not real Doom. It's actually more like Wolfenstein, right? But it's powered by potatoes, and it's real, right? So if you can do this kind of stuff on 1975 CPU, then that means that today, unless we do something really wrong, we're going to be fast enough. So what you should optimize your architecture for? And sometimes you have a very good answer to that. Like, for example, I only have 25 milliseconds to answer a request, right? So that's the latency that I have. Or maybe you have something different than that. But most of the companies should actually optimize on these two things, or get them architecture to be optimized on that. The first one is maintainability, or basically how much time will I spend on keeping the system alive, which means how much time I will spend on doing bug requests, on looking at the system and basically trying to define what's going on inside of it when somebody asks me for it, right? And then extensibility, which means how easy it will be to add new features. And if you optimize for these two, then most likely your business will be happy because it will be delivering more features and basically more business value, as they say, right? So, and then if you're a startup, then don't get fixated on these two. Instead, think about flexibility, or in other words, most startups actually do not survive long or do a pivot. And basically, what they try to do is they search for the marketplace, right? So for the market share and place on the market. So basically, what that means is build something that you can reuse. And that helps a lot. So with all that thing said, what we have right now, what I see on the market is actually 3 different architectural styles usually being used. And this is like the 80 or 90% of the systems that I see. And these are either modular monoliths, and I'm talking not about the good systems, because the bad systems are non-modular monoliths, something like a big ball of mud, right? We don't want that, so we are not going to talk about this. Then there is this distributed synchronous system, also called microservices using REST, right? And then, but it's only microservices if it's got independent deployments. And then we have event-based distributed systems, which are usually when you talk only through using events, and it's usually being used as a distributed system, so you got an event bus somewhere between your applications, right? Now, you can also build it in a monolithic way, but the benefits are smaller, much smaller than the normal way. Okay, I got my cat here, sorry for that. Oh, so anyway, with all that, let's talk about the modular monolith, and let's talk about its problems, because everybody can talk about the good things that those architectures bring. And sometimes you see people who say things like, okay, you should always start with monolithic application, or you should always build a microservice-based system, or anything like that. And it's not true. It's always about context. So let's talk about problems, because everybody talks about the positive things about those systems. First one is that whenever you have a modular monolithic system, you have a big risk of deployment. And that's because, well, a single memory leak will kill the whole application, right? So what I see is a lot of different companies actually try to mitigate this by making the deployment harder and make it slower, so that you're not going to deploy every single day, but you're going to deploy once a week, for example. And it's always a big event because it's a big risk. The problem is that the longer you wait, the bigger the risk. So it's actually, you should go to the other direction, which is continuous deployment and just being able to deploy it like twice a day, perhaps, or maybe even, well, after every single push. It's not possible if you're doing development with 100 or 200 developers, right? Then there's the broken window effect, which means that if you have something broken or a code looks ugly, then everybody else kind of like lowers their expectations to that level. And so when you allow for this, what you will have is basically going downwards with quality, right? So you have to educate people and you have to bring higher standards. And it's difficult because it's a cultural thing, right? Then it's easy to break architecture. And that's because, well, everybody has got access to this repository where everything is stored. And basically 1-2 weeks of your holiday and everything can be broken, right? So the way to mitigate this is first through education of each developer. And basically we are spending a lot of time designing systems and making sure that everybody is involved when designing systems, so they do understand the reasons, right? And then libraries like ArcUnit, which when you can use to basically check and make sure that the rules of those modular monoliths are there, or basically the communication patterns that you chose between those modules work. And then you have limited technology evolution. And this is the most problematic one for me, because what happens is that, well, you start a new system, you build a modular monolith, and after 3 years, your best people leave. They leave because they already know the technology very well, and they want to find something new, something shiny, something they can put their minds on, right? They are already bored by your technologies. And the problem is that it's very difficult in a monolithic system to actually, to evolve, to basically update or basically change the technology that you use. And you cannot have too many languages because the compilers won't work together. You cannot have too many databases, and so on and so on. So there is no mitigation for this. This is one of the reasons why I prefer to do microservices these days, right? Because with microservices, what you get is when you have, when the best people are bored, right? They just move to another application and build another microservice with completely new tools. That's what they do, instead of just leaving the company. And then the main problem with modular monolith is that people do not understand what a module is. And, well, there's a reason for that, because books don't tell you much about it. So I'll give you a definition of a module, and that works for me. And I'm not saying that this is true for everyone, but it works very well for me. Okay, so what is a module, and why do we have such rules for those, right? First of all, a module is something which is a vertical slice, which means it's got all the layers. If you remember the kind of an old way of building systems with a 3-layer architecture, this is database access, this is the basic, this is the domain logic, and then this is the presentation. You got all of this inside a single module. And why do you have that? Because we tried to modularize our applications in a layered way, and we know now that it doesn't work. It doesn't scale, right? Now, this type of modules do. So next, we have encapsulation, which means everything apart from the API of that module is hidden. You cannot access this, right? So when you talk between those different modules, they can only talk through the API, also called as facade, right? Now, this is important because we know when all the classes are public, sooner or later somebody will use them, right? And you end up with a spaghetti code. So you have to protect against this. So you mitigated this by just, encapsulating everything inside the module and just giving the API. That's it. Then the next one is the tricky one. A module has its own database, which doesn't mean that it has got to be a new Oracle system, PostgreSQL, whatever else you have. But every single module has got its own tables, collections of data, okay, in a database, and you cannot read or write into the database of another module. You cannot even do a join, select with a join, right, between tables from different modules. And that's very important. Why is it important? Well, through all those years, we found out that the trickiest part of refactoring actually some code is actually getting the database straight, because when different applications or different modules write to the same tables, then whenever you're trying to refactor something, you break the code in so many other places that you have no idea about. And that's because the SQL is, well, basically you cannot refactor it, right? There are no tools and no ways to do it. It's not, it's not strongly typed, let's say, right? So we know we have very good languages and ways to refactor stuff. But with database, that doesn't work too well. So instead of being able to read the database from another module, we are going to talk with the API of that module. And then comes the most tricky one. Well, modules should be responsible for something. And my point is they should be responsible for a process, not data. And this requires an explanation, and let me give it to you. So whenever you have a user in a system, basically, when people are talking about modules, they're thinking, oh, I'm going to create a user module. Now, what happens then? You will have a user that tries to register. Well, they will talk with the user module because that's where the user resides, right? This module is focused on data. Then you got a user that tries to log in. So basically, they will talk with the user module because that's where the data about the user is, right? Then another part of the system wants to authorize the user to do something, or one of the modules to do something for the user. And it also has got to talk with the user module. And basically, this user module grows. And every single module that is focused on data will grow and basically become unmanageable at some point. Instead of doing this, the real modularity is something different. It's about, finding the processes and being responsible for those processes. So in this case, instead of a user module, we'll have a registration module, which is only responsible for registration process. Authentication module, which is, as you guessed it, responsible for authentication, and the same for authorization. Now, the tricky part is, okay, so these are now 3 modules. But they do have different databases. They cannot read or write to the same database. So how do we do this? Well, they have to communicate with each other, right? So we can achieve it in a very simple way through queries, like, for example, authentication module. When the user basically tries to log in, the authentication module can ask the registration module for credentials. So that would be get credentials. Or the other way, which is to send an event where the registration would say, okay, I'm sending an event, user has just registered to authentication and authorization, which would require the authentication and authorization to store that information inside their own databases, but would allow it to basically not ask the other module about credentials or anything else. It's more natural actually in this flow, right? So when you add this type of communications, you will find out sooner or later that there are only 3 ways of how to communicate with each other, whether you are talking about modules or microservices. And these 3 are the query, when you say something like, you ask a question and basically you want an answer. So basically here you are saying, find available cars or get user credentials. This is a query, right? It's synchronous by nature. you can have a command which means do something for me. It's an intention, right? So this would be something like calculate cost for me, or maybe rent something for me, or maybe the registration module after the registration will say get the user logged in right away to the authentication module. And then you can have an event, which is stating a fact, something that has already happened, right? So this is asynchronous by nature, and this could be something like car was rented or user registered, simple as that. And the way you choose, the different communication patterns that you choose will define your system, basically, and how it behaves and what are the consequences. So let's have a look at this. This is just a query-only version of that simple part of the system, right? So you got the registration, but it doesn't send any events. Instead, authentication asks, is user registered when it wants to authenticate the user? But then let's say that we got another module which is responsible only for the password, right? So authentication could say, is password valid, and give it the hash of the password entered or something like that, right? So we can build on queries only. Then you can build on events only, where we would say like, okay, registration now says user has registered to authentication and authorization, and the password setup will say new password hash was set, okay? So now we can store this in our authentication module, right? So you can use the events, and you can mix and match them, but you will most likely not find any situation when you use both an event and a query for the same communication pattern. So basically for the same communication between two modules. It's either this or that, but on different modules you can mix them. Okay. Now, when you have this kind of a communication, when you have events, then you store that information internally. So our registration says user was registered, and authentication authorization actually tries to remember that, stores it into the database, right? So we are saving that information. Now, in this case, we are duplicating the data, right? So is that a problem? Is it a problem to actually duplicate that data? And 30 and 20 years ago even, we were told that this is a huge problem and we should avoid that. There was this whole thing in relational databases called the third formal form and the fifth formal form that was very popular, and we used that to avoid the data duplication problem, right? But what exactly is the data duplication problem? Well, you can get it down to two things. First one is the size. So when I remember my first hard drive, and my first hard drive had actually 40 megabytes, right? And that was like my third computer, because before hard drives, I used to have computers with floppy disks. And before that, I had computers with cassettes, right? If you have 40 megabytes of hard drive, there is not much you can actually put there, right? So back in those days, that was very important. Now, is it important now? When I talk with the developers in different companies, and they say something like, yeah, can you duplicate this? And they say, well, there's 27 million users here only, and I got basically the storage is pretty much free. So that will be, let's say, 3 gigabytes of data, no problem, right? So in extreme cases, this is a problem. But in most cases, that's not the case. That's not a problem, right? You can duplicate the data because the storage is really, really cheap, right? Now, the other thing about data duplication is the have data consistency. So we have learned the third and fifth normal form just so that we can have, like, we don't have this kind of a situation when in one table we have some data, and in the other we have completely different data on the same topic, and basically we don't know which one to trust, right? Now, the interesting thing is, when you're working within a monolithic system, that's not a problem, as long as you remember that each module has got its own database, and there is no communication whatsoever between different databases or between different sets of data. Why? Well, because you can have a transaction. So let's say that user actually registers here, right? They register here, you start a transaction. Then the registration actually proceeds, and after that, we are sending an event user registered. And we don't have to do it in an asynchronous way. We can actually call a method. That's completely fine, right? You don't have to have any kind of an event bus here, or asynchronous event bus. And so when the authentication is called with user registered event, then the authentication has got this, let's say in Spring, this little transactional annotation. And what that means is by default, it's going to actually join that transaction, which was already started by the registration module, and continue within it, right? So if it breaks, if authentication says, okay, I'm throwing an exception, something's really wrong, then actually the rollback will take all that data back from all those databases or sets of data. Now we see that this is a single database, just different tables or collections, right? So you can have a global transaction on a monolithic system, something you cannot have in a distributed system for performance reasons, right? And if you have that, then how can we actually lose the consistency, right? Well, you can lose the consistency very easily if there are any other modules writing to your database, any other applications writing to the database. But that's breaking the definition of a module that I just gave, right? So when you design those modules correct, the data duplication problem is not really a problem, right? Or not usually, unless you have extreme sizes. Okay, so you can duplicate them safely. And with microservice system or distributed system, you will have no other choice. Grzegorz?
Yeah, Kuba, there is a question about the transactions.
Sure.
I will show it on the screen so you can read it. Because we were talking about the transaction between the different modules, and Agnieszka is asking if it's okay to start with the architecture that have different modules under one transaction.
So this is I think this is just the example I just gave. You start a transaction on the registration, and then when you're talking with other modules, authentication, authorization, you continue that transaction, right? And you don't have to do much. If you're using Spring and you add the transactional annotation on the entry point to a module, so that's a facade, that's exactly the behavior you will get in most databases, okay? And it's completely fine. I see no problem with that, okay? Are there cases when there is a problem? Sure. If you're processing something very, very long, then you can have a problem where the transaction will, databases do not like very long transactions. That's it, right? But in most cases, not a problem at all, right? So you don't need a saga pattern. You don't need anything else. Just start a transaction and keep it going as you send information there. And don't get asynchronous. Basically, don't try to go into, just to a different thread, or you will lose the transaction unless you, of course, work with reactive programming where the transaction can be actually sent in the context, okay? Or the information about the transaction. So it can continue between different threads. So, okay, so we got that. So,
and we have second question, if
sure.
you can. What about the modules that need to communicate with some external systems?
Yeah. Okay, so when we have to communicate with external systems, that's the end of the transaction. That's not a module, the monolith anymore, right? We are now talking about a system that talks with different systems. And so if I want to do a rollback within my module, and I already said something to another system, how can I work with that? And the answer is you compensate. And we will see that when we are moving to the microservice-based system or event-driven systems. Basically, whenever you are leaving that single monolithic application that you have, you already have a distributed system, and then the distributed system rules apply. Okay, so you have to have things like transactional Outbox pattern. You have to have things like compensation. You have to have things like retries. You have to have a way to fix the information when you decide that information that you've sent is no longer correct. Okay? Any more questions?
No. Alexander, Maciek, if you don't feel that you got your answers, just let us know so you can join on stage and discuss with Kuba.
Yeah, it's going to be much easier if you just join and just, say your question.
Yeah.
Okay. But if you're shy, don't worry. I'll try to answer them anyway. So if you look at those modules, when they have their own databases, and we are in a single application, and we have our own tables, and you cannot talk with anything else except for the APIs, they look very much like a microservices, right? They look like candidates for microservices. Isn't this, over-engineering? Well, actually, no. This is the way that the microservices look exactly the same way is because that's the basic of the system of system, building blocks of a system, right? You try to build small pieces of software that can work together, but can be independent if possible, right? And this is the same thing as Unix philosophy. You try to get things that do programs that do one thing well, right? So I just told you, the module that you're going to have responsible for a single process, it does only one thing, but it does it well, and it has got the the database that it needs and doesn't have to search in other places, or maybe asks and communicates with other modules, because this is all fine as well. Okay? And then when you do it like this, then you start thinking in terms of, you know what? I'm not going to add a new feature to my module. Instead, because they're responsible for a process, and this looks like a different process or a part of another process or the end of my process or maybe the beginning of it starts with that process and then my process follows, then you can create new modules without changing the existing ones, which is actually much easier than to refactor anything inside existing modules. Okay, so think that this is much deeper than just, you know, monolithic architectures or modular architectures. This actually works very well because making small things that work and do one thing is easy. Okay, but there will be cases. Now, we had the case where we could choose whether we will use events or do queries. You never mix both, right? On a single call, on a single communication between modules. But there will be situations when you actually can't do it if you want the modules to stay the way they are. Here's an example. You have a user which says, I need to find nearby cars. And let's say you got two different modules. One for car rental, which knows which cars are available or not. And another one, which is locator, which knows the locations of those cars. So now if you would like to do, you know, I'm going to create a module responsible for that searching. So this will be kind of car finder. I need that information from both of them. So I will need to call get available cars and then do get car locations, or maybe the other way around, right? Now, the problem is that if you cannot do a join, and as I said, we cannot do joins between databases of different modules, then that's going to be very inefficient query, because what will happen is, first of all, let's say you will say, get me all available cars. You will get 500 cars. And then you will say to locator, get me all the locations of those cars. And then you're going to pass 500 different IDs of those cars. So that will be how many queries? Well, 2, but the second one is actually parameterized and it's 500 different IDs. So it's more or less like 501 queries actually, right? That's not very efficient. So instead of doing this, we would like to have a single SQL, like if you have a relational database, with a join basically, so we can get all that with a single query, right? But we cannot join the tables between different modules. So what can we do? This is an example where you have to go to just say goodbye to the queries and start using events, right? So here's how it would work. Locator can tell you car moved, so you can store the latest position of a car. And the car rental can tell you when the car was rented or when the car was returned. So you can mark the car in your own database, whether it's actually available or not. And then you have those two pieces of information inside your own databases in a single table, perhaps, so that whenever the user asks for, says find nearby cars, you got those cars right away. And if you think about it, this is faster than doing the join, because the join would be between two different tables. And now we can simplify the situation to have it only in a single table, right? That's data optimization. But basically, this is exactly the same thing we do when we do CQRS, Command Query Responsibility Segregation. It's optimizing for a read, right? By duplicating the data, for example, right? So here's a case where you have to use events to be performant, and basically because otherwise you cannot join that information on a database level. Okay. Now, all that said, there is one thing I have to warn you about events, right? Because a lot of different people that talk about the event-driven architecture says things like, okay, you know what, you don't even have to version those events, because when you send an event, it's true. And basically, it's something that has already happened. It's never going to change. It's always true. It's okay, right? It's the truth and only truth. That's it. Now, that's correct as long as we never make, as developers, we never make mistakes. Because imagine this, you got a car rental and then you got a cost calculator and you would like to say car was rented, right? What if you have an error in your code? And sometimes you will not say that, or basically you will send a wrong ID or any kind of an error that can happen there, so that cost calculator does not receive that information. Now, sooner or later, in that case, when you have errors made by developers, that's the situation when your different read models or databases in two different modules can diverge and basically have different sets of data. So now we have not only data duplication, but we have inconsistency between those two databases. How we can mitigate that? Well, you cannot mitigate the human error, basically, right? And it's always due to human error, because otherwise we would have a transaction on the whole thing. But now we are just not sending that information at all. So this is where you have to be prepared for a baseline. When you say, okay, we found a bug. Due to that bug, the cost calculator did not receive 50% of the events. And so now we would like to send those events again, or basically maybe send all the events, recalculate everything, right? That's a lot of work, perhaps, but it's very easy to do on the software level, basically, right? So whenever you're communicating with events, be prepared. You will most likely, after a few errors, will have to do a baseline. So it's sending all that information again, all that events again. Now, it's much simpler when you're working on a Kafka or any kind of a persistent data store that you can move back, right? Because then instead of resending them again, in theory, at least, you could just, in the cost calculator, read that topic from the beginning. But that's not that good, because, well, if the data was on the data on the topic was bad from the start, because you made a human error basically in your code, and sorry, that will not help, and you have to send everything again. So just remember that. Okay. Any questions?
Yeah, we have two questions. One is from Honza. How do you differentiate between the modules of the monolith and the microservice?
Yes. Okay. The way you describe seems like there is no difference. I was taught that in a monolith, you do share database. You can do join and so on. So here's the thing. A monolith is a single application, which means that you can have a transaction. That's a huge difference. A distributed system made of microservices is a lot of applications, which means that you will not most likely not have a transaction. You cannot have distributed transactions in a distributed system due to performance reasons. So that means that this is the main difference. It's not about, I can read all the data. Well, in theory, you can create a microservice-based system where all the microservices talk with the same database. We know this is an anti-pattern, and it's also actually called a distributed monolith. And you know that database is the worst possible tool for integration between systems, right? So we don't do that. And we've learned that about, 20, 30 years ago. Now we have to learn to do the same thing inside a single monolithic application. That's it. And I know that a lot of different applications are built this way, so you do have this shared database and you can search on every single table or repository. The problem is that it creates, every time I see it, I've seen it create so much mess that sooner or later you end up with a big ball of mud instead of any kind of code that you can manage, support, or you can write new features fast. That's the problem. Okay, first question.
Next one, Patrick is asking how to manage the many modules. And,
so how we will, let me read that. So we will have a lot of small modules responsible for one thing. How new developers that joined will know complete business process from test specifications. Do you have some teams? So of course, first of all, yeah, the behavioral specifications or acceptance tests in test of an application will explain to you the requirements, right? But again, how developers will learn about different business processes. We said that, or I said that, a module is responsible for a process. So how does that process of registration looks like? Well, you got a module for it, right? So it's not that difficult. And the last thing is, when you have modules, and you will have a lot of them, right? If you're building like one application with 100 people, you will have a lot of modules. Then most likely you will have an architecture diagram, and that architecture diagram will show you who talks with whom and how it works, right? That helps a lot. Okay, any more questions?
Yes, one more from Patrick. Can module be too small? Or...
Can module be too small or too specific? For example, revenue module split it for smallest modules, for example, current revenue, forecasting revenue. I will give you an exact explanation about how small modules should be in a moment. Okay, I got a slides about that and part of the presentation. So just wait for it.
Okay, so that's all.
All right, so let's move on. So this is the baseline. You will be prepared to have it. That's it. That's all I'm saying, right? The idea that an event sent once will always be true, that's correct, only assuming you never make any errors. And that's not true in general, right? Okay, now the next thing you have to understand is there used to be a concept called data ownership. And data ownership is when you have a single module responsible for some piece of data, right? Which we already know that the modules should be responsible for processes, and then it works much better. But when they are responsible for a piece of data, when they protect that data from being changed anywhere else, right? So I got this table, this is my database, I'm changing that, nobody else is allowed to, right? This is data ownership. Basically, the idea that you have to talk with that module to be able to reason about that data. But it also goes into the direction where you cannot make any assumptions. If you want up-to-date information about the user, you cannot just store that. You have to ask the user module or the car module for it, right? Now, the data ownership idea is completely irrelevant when you have events. Okay, so when you mix and match, and basically you have a system where there are queries and there are events, data ownership doesn't apply anymore. What applies is a single point of truth, which means that for any single statement in your system, whether this is an event or something else, there is only one place that can make that statement. So for example, if I have a car rental module and it's got the car was rented event and it sends that information, it's completely safe to duplicate that information and store it in as many different modules as you want, because you have a transaction on top of all of that, as long as only car rental is available to state that statement. So basically state that car was rented. We really need that single point of truth, because otherwise you will not be able to trust anyone. You wouldn't, if you have two different modules that would say car was rented, who do you trust, right? When you write the code, it gets too messy and too complicated fast, right? But no data ownership, the data can be duplicated. It's just that the source of the data or the source of the statement is a single source. That's it, single point of truth. Now, when you have that, this allows you to ensure invariants, which are rules which are always correct, right? So, for example, if we want to rent a car and we want to ensure that only cars which are not yet rented can be rented, then it's got to be made in the car rental module. No other module can do it. And it's easy to do because, well, in car rental, we know which cars are rented, right? So you just use an optimistic log or a pessimistic log on DB inside your car rental module. And that's pretty much everything you need to make sure that you will never allow to rent a car that is not yet, that is already rented, right? Now, after the car is rented, how do you know when you basically rent it again? Well, you wait for an event called car was returned, for example. And again, car return can actually make those decisions, right? Now, this can be more complex, but we don't have enough time for that. But just remember, single point of truth is necessary. Data ownership is not. Okay, data ownership is not true anymore. Copy the data as you wish. Now, how small those modules should be? How can we protect against them being too small? Okay, so here's the thing. For many years, I thought that modules should be no more than so many classes or so many lines of code and stuff like this. This is completely wrong. I've learned better, right? It's not true. It doesn't matter how much code you have. What matters is something completely different. But let me show it to you in an example. Let's say that you want to send an invoice to the user through SMTP every single night. Basically, at the midnight, you have to get the cost from some other module called cost calculator and create an invoice and send it to another user, right? Now, most of the developers, when they see a situation like that, they say, okay, I'm going to have invoice creator module, right? And that invoice creator module will actually do this job. And then I'm saying, isn't this module too large? Well, why is it too large? It's just a single process, right? We are sending the invoice. Well, let's have a look into the details of that process. What actually is going on? Well, the first step that we have to do is we have to get the cost per day for that user. Now, when we do this, we have to calculate that invoice. So what does it mean to calculate the invoice? Well, you have to learn about taxes. You have to learn the definition of the invoice. Basically, you have to learn all the financial implications of having an invoice. What does it mean? What should be on the invoice, right? It's not a simple template. It is much more complex. So you have to read a lot. And you have to read the law, right? You have to read about, the taxes and stuff like this. Now, the next step would be to create the PDF file, right? Well, that's simple. I just have a library here, and I'm going to call that library, and that's it. Well, if you ever created a PDF using a PDF library of any sort, you know exactly that this is going to take you a week. And the reason why it's going to take you a week, because it's, it's basically very problematic. Like this basically is a simple job, but for some reasons, I have those lines basically go over those pixels and everything looks bad, or maybe the margin is incorrect, or maybe anything else. So to create a PDF, you have to learn what? The taxes? Not at all. What you have to learn, what you have to read is all the documentation about the PDF library, then Stack Overflow about that PDF library, and then you have to basically, through a trial and error, find out how to make it so it looks good. Okay? Now, that's a completely different area of knowledge in terms of what you have to learn. And then you have to send it through email. And that's not very complex, right? Because nobody implements SMTP themselves. They're going to use something like Spring Integration, where it's just one class, or maybe Apache Camel, where it's just a single line of code, right? Now, here's the problem. You have to read the documentation for Spring Integration, or the Apache Camel for that matter, right? And those documentations are actually huge. There's a lot of different stuff that those libraries do, so you have to read that. You cannot just copy-paste the code from internet, although a lot of people try that, right? So you read all those documentation, and you spend a week on learning and trying this library, and then finding out how to make it send that PDF finally in a most efficient way. And when you think about it this. The invoice creator, this step requires a different area of knowledge. You have to learn something completely different than what you have to learn when creating PDF generator, or this part of the process. And then email sender requires a different learning, basically, right? So what that means is that you can implement this in 3 different modules. And if you do so, you will have 2 benefits. The first one is you can have now 3 people working on those 3 different modules in parallel, right? So that's great because we can speed it up. And then what you also have, even if you work if you're the only person working on this, if you create it in 3 different steps as 3 different modules, then when there is a bug, you will have to go back to that single module and basically take the documentation again and read it again. But you will have less documentation to read because you will not have to mix taxes and the PDF library documentation and the Apache Camel documentation. Instead, you will focus only on that one area of knowledge which was necessary to implement that step of the process. And that brings me to the conclusion here. Now, what we are trying to do here is we are trying to optimize for a thing called cognitive load, right? Modules should be as small as possible in terms of cognitive load. And cognitive load usually means how many things you have to read, how many things you have to remember and think about. If you have too many things to think about, then it's very hard to implement something because you have to mix that knowledge and I don't have too much memory in my head. But if you can minimize this so that, now I'm implementing on the invoice creator module, so I have to learn about taxes, but I can ignore PDFs. That's much easier to do, and it's going to be faster to implement that step than if you had to take everything into account. So I would say right now that modules should be as small as your cognitive load allows, or in other words, if you can read one piece of documentation and create a smaller module with only that piece of documentation, for example, taxes, right? Then do it. And if the PDF is a completely different source of information, the source of knowledge or basic documentation, then that's another module because you can then read the next one and basically forget about the taxes. It pays back. Whenever you're working with those modules, it's going to be much easier. And it doesn't matter how much code is there. It matters how much things you have to put into your head. Questions?
Yes, let's start with the last one. Michał is asking, but in this time it will be like this. So about the size of the events that we are sending between modules.
Okay, how big events could be? Fields, line, or in kilobytes? What if we need to send large amount of data between services? Is it good to send a reference to that data inside the event that is accessible by both services? That is sharded blob or something? That's a complex question, and it depends. Because first of all, let's say that, well, whenever you're working with a monolithic application and you're just sending events, which means you're storing that information in memory, you already have that information in memory. So the cost is 0, right? If you got objects, you have 5 objects, each of them 5 megabytes, you already have that in memory, right? So then sending it to another module doesn't mean anything from the perspective of the memory, of course, unless you're overdoing it a little bit. But then when you are having a distributed system, then you have a problem. Because first of all, if you are sending those events, let's say, through REST API, right, they can get much larger, and basically you can have them in gigabytes, right? But you have to process that gigabytes on the other end, right? So how can I process an event with the size of 1 gigabyte? I will need a lot of memory to process that. So we don't do it, right? And it's hard to get those events, but big like that. And if you have something like an event bus, let's say Apache Kafka, right? The maximum size of the message is defined. It's not unlimited, right? And there are good reasons for it, from the optimization perspective. So you cannot have it larger than something, like 1 megabyte, for example. I think the 1 megabyte is actually the default in Kafka. Now, having said that, there are sometimes things you have to send which are really large. Let's say, with this example we have on the screen, PDF generator creates a PDF. How large can this PDF be? Well, if there is a lot of costs for that user, this could be megabytes, right? So should we send that event basically to email sender? And should we send it as an event when it's another system, it's a distributed system, so it's another application? And the answer is, if this is the same monolithic application, then you already have that in memory, so you can send it directly to the email sender, no worries, right? Because you don't store that data yet on the disk, assuming you didn't. But if this is a distributed system, it makes much more sense to actually store that potentially infinite PDF in some kind of a bucket, basically a file system, and send the event PDF created to email sender with only fields saying like, okay, this is a PDF for this user. This is a link to that PDF, so basically URL, ID, and saying what happened. And that's it. And email sender can then reach for that data and handle it itself, right? But this is from all those complications are due to the technical facts that you cannot have infinite large events in an event bus, for example. When you already have that in memory, doesn't really matter that much. You already have it in memory, right? So in monolithic application doesn't matter. Distributed systems, it matters a lot. Okay, and the sizes that you're going to work with in Kafka by default, I think it's 1 megabyte, and that's the size you're aiming for, more or less. If you got something infinite, most likely you will store it somewhere. File system is not bad, and you will send only the URL for that. Okay, next question.
I'm not sure if you are ready for this. I will show it. That's the part of this of the question, and I will invite Greg on stage. Okay, do you want to talk to Greg about this question, because it's just a part of the question. Greg, you should have invitation here. Okay, and you need to turn on the camera and microphone. Yeah, we can hear you, Greg.
You hear me?
See. Yes.
Okay, I apologize. My question was a bit long.
Yeah, that's why I invite you on stage.
Well, because I was giving out a very specific scenario, because just asking the question in general would not have really been fair. I wanted to give one for your domain. So part of your domain is a bit unusual for event source domains, and it's worth having a bit of a focus on for people that are here. The example I'm going to lay out is going to take less than 1 minute. I promise not to talk too long.
Go on.
You mentioned in the talk, car was rented. What if we have an error in our code discussing in particular read models?
In monolithic systems or distributed ones?
Dealing with events in particular. But for me, the read models would be the least of my concerns. I'd be much more worried about what happens further down the causative path as much as what we're doing is speculative. As an example, we might have car 3 was rented, and then we have car 3 was marked as being expected to be returned to Sao Paulo on date and some date. Car 3 preemptively rented in Sao Paulo to go to Los Angeles. Car 3 preemptively rented in Los Angeles next Tuesday to drive to Seattle. And then we end up with car 3 was late to Sao Paulo. we might end up with these speculative things that are occurring. There might be hundreds or even thousands of them. How do we deal with the dependency graphs between them?
Something like domino model, right? And the domino effect, that something broke at the beginning and what happened at the third step.
So from my perspective, or at least my experience, because that's the only thing I can talk about, in monolithic application, well, simply that's not the problem, because you can roll back the everything because you have transaction on over top on all of that. In distributed system, that's a completely different story. And so when we are working in large distributed systems with a lot of different teams, what happens is you cannot reason too far, right? So I don't know what's going on beyond the teams that I communicate with, assuming I know who I communicate with. Because sometimes I even send events stating facts, okay? Something had happened, like a car was rented, right? To a public topic on Kafka. And I have no idea who's going to use that and what they are going to use that for, right? And so what happens now when I discover that, well, the car wasn't really rented and there is a problem with all of this, right? And so I have no idea what's happening in the rest of the system. Now, I'm not sure whether I understand the problem that you described correctly, but we have this kind of a situation when the domain that I work with is actually about charging electric cars. And so we receive a lot of information from the charging stations about the state of the charging station. And there is a lot of different things that can happen to a charging station. And sometimes those things make no sense from the perspective of a service who actually receives all those events and tries to build a read model on that, just trying to find out where the hell that charging station is located, for example, right? So we had so many problems with this approach when you have to rebuild basically the read model on every single service that tries to reason about what does it mean that the charging station actually works here, or what was installed there or removed there, or the connector was removed on that charging station. And there were so many problems with actually trying to correct the read models by, oh, we stated something, and now I see that I had an error. We need to state something again to fix all the read models in all the different parts of the system, right? And I don't even know who else is going to use that information. Then with this type of problems, we ended up actually sending snapshots. So we are not on stating the facts that happened, like things like the car has moved or the station was installed. But we have this single service that basically gets all that different things that happen for that particular station. And then it creates an event called station snapshot, which says, okay, so this is how the station looks like right now, no matter how it happened and how it got here, right? This is not event sourcing. Right? I'm not saying that I'm trying to prove and basically make sure that the current state comes from all the events back. I'm saying that, okay, I had those events back and maybe we made some errors. There were so many people working on the system. Some of those events were untrue. Some of those events, well, you got duplicates, of course, and everything like that, right? So sooner or later, we are sending just the snapshot and saying, you know what, this is a total mess, but we fixed that. And here's the situation, here's how the station looks like right now. And for example, with the EVSEs or the charging station, what we have, we have two topics. The one is actually the station snapshot, which is the basic topic where you can use the Kafka, basically Kafka topic and reduced topic and basically read model on top of that to be able just to query, I want this in-memory model about, where those stations are located. That's it. That's all I want. And then you have another topic where when we have station statuses, which means in what kind of a state that station is, whether it's charging right now or whether it's disconnected or whatever else. Because there are so many events about those. And it turns out that most of the microservices that we have are actually either interested in the location of a station, and basically they want the kind of a snapshot to build a read model, or to want to react. And when they want to react, they want to react on a event like maybe the station is charging right now, right? So they cannot have just a read model. They want the real event, something that in the domain really happened. And what that means is that whenever we are fixing something, when you have to fix a station snapshot, or basically the location of the station, it's very easy because you just send a new station snapshot, and you're not trying to reason how did we get there in terms of the recipient or the consumer. But when we're talking about the station statuses, then we are not even trying to fix this. Instead, you treat it as a new message, basically saying, you know what, doesn't matter what kind of a status the station had, whether it was charging or not, right now it's charging, believe me, that's it. And so this simplified the situation when we were propagating errors by saying, oh, the station was installed in this single place, and then another service would take that and basically reason on top of that and pass something else, and so on and so on. By providing a single place that you can base your read models on. So that helped us a little bit. But to be honest, I'm not completely sure I understand whether this answers your question, because I haven't wrapped my head around your question yet as much. The cascading errors, we had them, we fixed them by providing the read models based on a single point of truth. And that single point of truth has got a database and basically decides whether it wants to send a snapshot, so rebuild all the read models for everyone else, or whether it just sends events like the station is charging, so that you can react on the event and the business event that happened.
Well, the errors there's two different types there. There's the first type, which is just we had an error in our snapshot, whatever. That's relatively easy to deal with. The second one is we actually have cascading errors, where we had an error and that error caused us to make another error, which caused us to make another error, which caused us to make another error, which caused 17 other errors, which can we come down a causative analysis of those errors?
Without event sourcing? Without event sourcing, I don't think we can, right? We can fix them somehow. But without even sourcing, basically we can't move back and basically reason about that, right? Okay, so does it answer your question? I suppose not. Do I have problems with cascading errors? I definitely do. How do I protect against them? I protect by rebuilding read models, basically, right? So, and if they are in the read models, it's quite easy to rebuild. What do I do if I issue an invoice to somebody and you can't change that, and I've already sent that invoice to somebody for charging on a station with your car and so on and so on? Well, we compensate for it. So basically, that's the difficult part, or basically that's the part that takes a lot of time, but we have to fix it, and we have to send, the corrective invoice for every single person. And whether this is in our system or in other systems, we have to do exactly the same thing. We compensate, and it takes a lot of time.
Okay, thanks.
Thank you. Okay, any more questions? Okay, who is responsible for creating and assigning an ID? Are they system-wide? And so on. Now, that depends on what type of an ID we are talking about. When there is an ID of an event, so let's say I'm sending car was rented, you can have an ID of the message itself when you're saying, oh, this is the message with ID number 5. So that when you receive it again, you can deduplicate it. And basically you said, yeah, I already handled that message, right? So whenever you have topics on Kafka, well, the topics on Kafka have IDs or keys, but basically that's a different story. So you can have IDs given by a single module or microservice inside an event. Now, the different thing is, let's say that we say car was rental, and there is a rental ID within that module or microservice, right? We are saying that car was rented, and here is the rental ID. When you see another event called car was returned with the same rental ID, that you know exactly that this is the rental that you have just finished, right? And of course, that happens inside the module that makes the decision about, renting the car. Or if there is a module about returning the car, it has got to know that information as well, either to match, or even better, in this case, I would use JWT and basically the token, and the car return has got to understand who that car is returned for, or basically which event it was, right? That's it. So who's responsible for creating and assigning IDs? Every single module that creates the events, I would say. Any more questions? Do you manage all the modules code in a single monorepo? If not, how do you manage versions of the cross dependencies? So here's the thing. If this is a monolithic application, then you can have a single monorepo, right? If this is a distributed system, then what happens if you have different teams working on different microservices, which basically can have modules inside of them, and this is usually in different repositories, and it pays off not to have a single monorepository, just for the reason that you will not have any problems with people messing with your code. Only my team can access my code. Basically, I give read access to everyone else, but the write access, you can make a pull request. That's about it. You cannot make a commit to my code, right, and push. So do we have cross dependencies? Yes, we do, because we have tools. And we also write tools to solve specific problems. They are usually not domain problems. They are usually like a library kind of a tools, right? And then how do you deal with, different cross dependencies? So if I have a single tool and I got that tool being used in car return and car rental and US car locator, what happens? And the answer is nothing. Because you don't care. You don't have to upgrade all the tools at the same time. Unless, of course, in that tool or that library, you put all the DTOs, or basically you created a kind of a shared kernel, or basically a published language, or basically a jar where you keep all the classes. That's not that you use for basically those contracts between different modules or microservices. That's not a very smart thing to do. I would say don't do it. Just, duplicate the code, and basically I'm sending you some event. If you want to deserialize just a few fields, you got a completely different class there. And so we don't have this kind of a situation when we have to have different versions and we have to update all of them at once, except perhaps for the security bugs. Or if you find there is a security problem, right? And you have to update those libraries, you have to update them everywhere. But it doesn't matter, when you do it. Or basically, you can even leave one single microservice without that update, and it will still work, right? Because we don't you use contracts for this if you are doing the distributed system. And in a monolithic application, this is a single repository. That's it. If you have to have several repositories, to be honest, I don't have much experience with that, because I always tried to keep my single monorepo where I was working with monolithic application, and then have as many repositories as possible when I was building distributed systems. Okay, what about API versions of dependent modules? Yeah, so basically, what about API versioning? And the answer is, if it is a monolithic system, it's very simple, because you have a compiler, right? It checks the version on both sides, and you deploy the whole system at once, all the modules all together. So it's, as long as it compiles, it's always okay. As long as you can pass the integration test, it's always okay, right? Now, in a distributed system, what you have to do is you have to use consumer-driven contracts, and that will provide you the security that one module changes the API version. As long as the contract is still applied, that doesn't matter anything for anyone else, right? But if it breaks the contract, you will want to know that before you go to production. And that is when building the system on your machine. And that's what consumer-driven contract libraries are for. And two I can recommend is, first of all, Spring Cloud Contracts, if you're working with Spring. And the second one is Pact, because it's so popular, but that actually it's, well, I have to recommend it because everybody is using that, but I can't recommend it as in, it's got its own problems in terms of, it's not that simple. I prefer Spring Cloud Contracts, but it works. Both of them work, and basically you can be happy with that. And of course you will have versioning, but that's just the API version. That's a standard topic for any distributed system. Okay. I meant the ID of the car. How do we know that we talk about the same car when we say car has been rented or car has been returned? How do we refer to the car itself in the events? Okay, usually you use an ID for that. How can we know that this is the same ID? Well, first of all, if somebody is renting a car, you get an ID of that car, because otherwise, how do you know which car to rent, right? So it's usually at the source. And when somebody is returning that car, you will either get the ID of that car that is being returned, or at least you will get the username, right? Somebody's trying to return. So let's see which car was rented by that user, right? So either way, you always get that propagation. So I don't see a problem here, at least not in the systems I've done. What do you do when you add a new service to the system and it needs to build up state from events from other modules? A very good question, right? So if we add another module here, it doesn't know anything about car was rented, car was returned. So again, the answer is different depending whether this is a monolithic application or microservices, right? Or distributed system. In the monolithic application, what you can do is you can send those events to that single module basically just by, triggering this. And so basically you have a trigger there and you're saying, okay, send that event again so that it can store all that events. Or, as I said, you can send a baseline. When you say, you know what, everybody look up now, we are going to send the car rental about the current status of the rented car, so car was rented event to all the other modules so they can rebuild their read models. Or, and that's when we are building these large systems with event-driven systems about charging cars, what we found out is we have this, for this type of rebuilding the read models, we have Kafka, right? So we have an event, like I gave an example, station snapshot, which says, this is a station, this is where it is located, this is its current state, right? And so there is a topic on Kafka which has got all those stations, and it's a compacted topic that you basically have the last event per key, and the key is the station ID or station name, right? And so when a new microservice starts, which has got a new module, what it does is it reads those events from the beginning, or basically from not the beginning of the time, but from the beginning of that compacted event, and rebuilds the whole read model locally, either in RocksDB or in memory, by just checking, so I got 1,000 stations, these are all the IDs and their states. And I can do it easily because that's how Kafka works. You read a file from the beginning to the end. That's basically the whole concept of Kafka, right? So rebuilding based on Kafka is very easy, okay? If you have to fix something, you do the baseline, or you send those events again, or basically all the events again, because sometimes you just, I got millions of events. I don't want to think about how many events I've lost. No, we found the bug. We want to fix that bug. Let's send everything back, right? And rebuild those read models. But you have to think about whether this event is only for the read model. So this is just like the station snapshot when you're saying, doesn't matter what happened to that station. This is the current state. Or whether what you are sending is an actually action or something that happened, an event, real event, when you're saying, oh, this station is charging at that moment, at that very moment 2 years ago, right? Because when you're sending that as a baseline again, and you're issuing invoices, you can have side effects that basically you will not be able to protect against. But in truth, you can protect against that as well, because events can have their own IDs. And then you can basically duplicate them. So say, oh, I already managed to fix that event. There is another problem, which is, what if my service or a module is idempotent? So basically, if I get 2 events about the same thing with the same ID, then I ignore the second one, right? What happens if the first event had an error? And in that situation, what do? We actually go into that database, drop the whole thing, and resend all the events again. Because, well, now we get the new events, which is basically the same as the old events, but they are fixed. They don't have the error that we used to have. And because that service is going to ignore every new event about, that fact, we have to basically clean the database. And that's very problematic.
Okay, and last one, you talked about it, but I'm not sure if you want to add.
Column-based databases encourage duplication of data. If you want to avoid joins, duplicate data. How to manage these designs to work in distributed microservice architecture? Well, in distributed microservice architecture, you have to duplicate data anyway. Why? Because there is this thing called speed of light, which means that if I have that data in 3 different microservices, no matter how fast I'm not going to be faster than speed of light communicating with that microservice, and this microservice. If I want to be real fast, then I have to get that data back and basically duplicate it. So get the events here, create a read model in a local memory, or maybe on a file system, or in my local database, let's say, and then I can answer the question faster. This is called data locality. You have to be local in terms of when you are trying to answer a question or do something for someone, you have to have that data already. You cannot have any time. You have no time to make any other queries. And that's the basics for an event-driven system when you have to have those read models and the local data locality. So you will have to have that. And that's exactly the same as the column duplication, except I don't have much experience with column-based databases. I think I know only one of them, and I have used it like for just a little bit. So sorry for that.
Okay, so that's the last one.
Okay, cool. So let's move on. So that was the single point of truth. Okay. Now this ensures invariants. I already talked about it. Let's do something else. How small modules should be? We already talked about this. So now let's go into the synchronous microservices, because I was actually talking about modules in a monolithic system before, even when we talk about events, because we can have events in a monolithic system as well. So first of all, the definition of microservices is this: either you can deploy them independently, or these are not microservices, right? And that's not my definition. I actually stole this from the author of Building Microservices, who is called Sam Newman. And he's one of the precursors, let's say, of the term microservices, so I think he's correct. So independent deployments. Now, what are the problems of synchronous microservices? Okay. Because everybody talks about, I'm having so many microservices, it's so great. What are the problems? First of all, eventual consistency is the maximum that you can achieve due to the speed of light. So basically, you will have a lot of read models if you want to be really fast enough, or you will cheat by using a cache. And these days, I don't use a cache at all. And the reason for it is because, well, a cache, if you think about it, is a query with invalidation of information based on an event. So basically, the source of the information that I'm caching sends me information. You know what? That cache is invalid. Or I can have time-based invalidation, but it's very rare because, you know, basically you have this timeout. So you don't have that information as fast as possible. And when you do this kind of communication where I'm going to ask you for something, but you're going to send me information when it's not true anymore. So how about you just tell me what's true when that happens? And I can build my local database on it, which is why, well, if you're using Apache Kafka, you are not going to see a lot of caches, right? That's how we do this. So this is these are the read models, and you have to deal with that. You have to live with the fact that you cannot have strong consistency, and it's okay. The whole world works like this because, well, speed of light. And then the next problem is it requires DevOps. And I'm not talking about a single team responsible for, I don't know what, called DevOps. If you have a team called DevOps, you have already failed. That's not microservices. DevOps is defined as developers operating their own system on production, which means that if my team has got 15 microservices, the other one has got another 15, and we got 10 teams like this, every single team operates only their own microservices on production. Why is it necessary? Because, well, I don't know what kind of how large your operations or the teams for operations are, but those teams are not going to survive 200 microservices when I build them, okay? And also one more thing, if developers do not operate their own system on production and they have so many microservices, the problem we see is that they start to build really shitty systems. They don't care about observability, they don't care about consistency or basically the let's say transactional outbox pattern. They don't use monitoring. They do not provide monitoring with the systems, and so it's very difficult for operations to handle that. Okay, so either do DevOps or don't do microservices at all. And here, developers operate the system on production. Next thing is that it requires a team for tooling. Now, when you have like maybe 10 or 20 different teams working on a single distributed system, then sooner or later we will find out that there is a lot of stuff that we use that is shared, like, for example, the Kafka cluster, or maybe the Kubernetes cluster, or maybe the monitoring tools that we use, right? Sooner or later we will find out that one of those teams, or maybe two of those teams, or three of those teams are going to be involved only in building tools for other teams. And it's okay. It's called, you can call it platform team, you can call it a library or software as a service team. When you have a large corporation, and we're talking about, 1,500 people working over 1,500 microservices, there is actually a lot of different tools for those business teams that create business value. And there's a lot of tools, and those tools have got to be managed. So basically, there's a lot of tools that teams that only do tools for other teams. Okay. Now there is a book called what is it called? Team topologies that explains this a lot. But I see this in practice everywhere, right? So you expect you will have somebody who will only do the Kafka monitoring from now on, or managing, or maybe even create tools for other teams. And then you got the communication complexity, which means you require retries, fallbacks, circuit breakers. You need to learn a lot about resiliency and stuff like this, and it's complex. There are libraries for all of this, but it's actually getting complex. Okay. And the last thing is, you will only notice that you have problems in asynchronous microservices when you actually monitor them correctly, and that requires observability. Basically, you have to be able to say what's going on in my system as it works, not after it dies. So what does it mean for me? Well, my approach to observability changed a lot in terms of when I started to do microservices. Right now, when I say that I want to look at the logs of my new microservice, of a new module, and I want to be able to reason about what's going on inside of it based purely on the logs and metrics. If I can do it, whenever there's, I have an integration test and it fails. If I can go into the logs and without any breakpoints, without any debugger, reason about what happened and why, then that means I got good observability on production later on. If I can't, and I have to make a breakpoint and basically put my debugger, stop my debugger here and see what's inside some field or whatever, that means I got bad observability and I'm not good. I'm going to have hard time on the production to actually say what's going on when shit hits the fan. So I would say mitigate that with education. So the next problem is with synchronous microservices, if the system is not reactive, like you're not using reactive programming, or it's not a driven event system, because driven event systems are quite reactive by nature, then you have suboptimal CPU usage. How is that possible? Well, think about it this way. If you have a monolithic application and 100 developers, there is a big chance at least one of those developers will know what kind of thread pools you have in your application, and will have experience in customizing those thread pools, and maybe they will have experience in creating stress tests, and then they will have experience in tuning those things where you have GC and you have the driver to the database and you have those web serving threads, right? So that the flow is optimal. But when you have 20 microservices, 5 person per team, and each team has got 16 microservices, and so not 20 microservices, but 200 microservices, something like that, right? Then if you have 5 people and we have 16 applications, there is a large chance that we don't get that single person who knows about threads and understands the threading model. And I talk with a lot of developers and I ask them, what do you use? And they say, oh, I'm using the most popular Spring Boot with, Tomcat. And that's it. And the database driver, right? And a relational database. So I ask them, okay, what are your thread pools? Well, there is one thread pool for Tomcat, I suppose, and one, well, I suppose for the database. Okay, how many threads do you have in those thread pools? And 95% of the time they don't know. So what happens? Well, your system is getting slow, your microservice is getting slow, and you're already used up all your threads. Okay? And if you don't know how many threads you have, and basically you do not monitor that, what happens next is that, okay, you say, okay, so I'm going to spin up another microservice. So I'm going to start a new microservice that will handle the load because I have, I can scale indefinitely, in a horizontal way. Beautiful, right? But each of those microservices that is using, let's say, 2 cores on your node actually only uses 10% of the CPU because, well, there is a thread starvation. Basically, you got 200 Tomcat threads, only 10 he carried the database driver threads, and one of those pools is not correct comparing the loads. So basically, there's much less chance that somebody will know how to optimize those things. If you want to get away with it, so you don't want to have every single team learn how to optimize thread pools, then what you can do is you can move into reactive programming using things like React or on Java, for example, or in event-driven systems where the number of the events that I can take in a, and basically handle at once is the number of the cores I have. And if all I do is communicate with events, and then I have the asynchronous maybe database, or maybe I'm just sending events over, I can use 100% of the CPU without even thinking about more threads. I only have 2 CPUs. That means only 2 events can be handled at once. That's it. And then you have no end-to-end tests in synchronous microservices. And why is that? Well, because it's impossible when there are different microservices can be deployed to production independently. It's impossible to have a testing environment which resembles the production one-to-one. It's possible when you have only one team, but the more people you have, the less possible it is, because, well, we have 60 microservices in production in that part of the system. So how many deployments do we have? Well, we have a lot of different deployments, and sometimes though there are rollbacks of those deployments. So if you wanted to create this kind of a system which resembles the production, it will always be out of date, and basically you will never be able to prepare the kind of testing environment that will work correctly. And I remember while working on a company with 700 microservices, which is Allegro, I remember we had this kind of virtual testing environments. They were never up to date. They were useless, basically. So instead of doing end-to-end tests, you have to learn to testing on production and to test before production, but even before the test environment, because the test environment is not reliable anymore because you cannot get it one-to-one with production. So how do you do it? Consumer-driven contracts. That's how you do it. And behavior-driven development, test-driven development, things like that. Any questions? What do you prefer to use for asynchronous communication? Kafka versus solution built on top of Kafka. For example, Allegro Hermes versus vendor-specific products like Google PubSub. Okay, I do not like Allegro Hermes, which is a solution built on top of Kafka. The reason for it is I know why it was built, what it was built for, what problem they were solving, but it stops developers from using the power of Kafka, which is all those read models, stream processing, and so on. Okay, people think in terms of REST APIs, but that's very specific for one single company called Allegro, because I don't believe anybody else uses that tool. Now, in terms of a specific product like Google PubSub, now I prefer Kafka to any third party that is, not open sourced. And the reason for it is very simple. First, because open source software has better documentation, much higher usage, and so there's a lot more things you can find out. And second one, the companies that create open source software are not arrogant, because if they are arrogant, then their software is not being used. Now, on the other hand, the cloud providers, for example, they can be quite arrogant. They can have an idea and they can force you to use that idea because you have no other choice. Because, for example, your company has to get an agreement with them, right? And so what happens is that I haven't seen too many stupid ideas in open source software. I see a lot of stupid ideas that do not work for my cases. They work perfectly for Google. They work perfectly for Microsoft. Do not work for my cases because they don't care about my cases. They don't think about me, right? And open source software is better for that. And the next thing is, well, if you are using Kafka, you can have indefinite persistence. So basically, you can have the events from the beginning of time, as long as you have enough storage. And I believe that all the cloud providers do not provide that. Maybe I'm incorrect about Google PubSub because I don't use GCP a lot. But when we are looking for alternatives, for example, on Azure, it turned out that you have an event retention of 2 weeks, which means that after 2 weeks, the data is gone, which means you cannot go back to it, right? And that's important when we want to, like, for example, send a fix of an issue or of an invoice, right? Because it's not the end of the month, so we can still fix that invoice, So I prefer Kafka. I think Kafka is pretty cool.
Okay, one more. We go to the serverless.
Oh, yeah. It looks like ideal approach for to create system in Unix way, so maybe it's the direction. Well, after so many years of working in PHP, which was my first serverless platform, okay, I would disagree. And the reason for it is there are very specific reasons. I think there is actually, maybe I should point out, I'll try to find out there is like a serverless woes or problems with serverless written by, I think the Serverless Polska or something like that. There's like an organization for, not organization, but like a community for it. And they wrote a lot of good points about serverless, what you have to watch out for. First of all, it costs a lot more because you get another level of abstraction, right? It's not going to be cheap. So if you have a stable traffic, at some point, the cost of that traffic, okay, you will try to bring it down. And the best way to bring it down is to actually, take the money back from whoever you're paying to. And so serverless is much more expensive from my experience than, for example, having the same traffic on Kafka cluster, right? But it scales so well. Yeah, sure. Does my traffic scale so well? Like, do I have 10 times more traffic? No, so I don't care, okay? Then the next thing is, oh, but it's so easy to create those things. You write a single script in JavaScript and then it works, right? That's perfect. Have you tested that? Where's your unit tests? Where's your integration test? How does a testing approach work, right? And then you find out that a lot of these people who work in serverless, and I think that was one of the wordings of the Serverless Polska, was that the people, because it's so easy, approach this the same way they did with PHP, which means they don't care. They're like, yeah, I'm going to break stuff. I'm going to just build a new Facebook. I'm going to build all those things on top of different things. And when you have to support it 3 years from now, that's when it breaks, and that's when you have horrible time. So from my experience, serverless is great if you have, first of all, if it pays off. So if it's sporadic traffic, basically there's not a lot of traffic there, and so you can pay for that. And the second thing is when people who actually implement this are real good engineers and not some just people who, are doing happy coding and I don't care, testing. Why? You have the serverless platform. You can see whether it works or not. Well, now try to change that code and refactor it. Good luck with that. So if you got good people, not a problem, but a large cost. If you don't have good people, the problem is there's a lot of bad people that are going to, work on serverless, and you have to get rid of them or teach them.
Thanks.
All right, so we got that. Now, the interesting thing that in microservices, you have to consider another thing, completely different thing than what you have in monolithic situation, which is you have different quality requirements. And quality requirements are things like SLA, for example, right? So I will explain that in an example, because in a monolithic system, when you have an SLA, it's an SLA for the whole thing, right? Service level agreement for the whole thing. Either it works or doesn't, right? It's not like, that process failed, but everything else works. If you have Java, and this is a monolith in Java, you have memory leak, basically everything will die, right? So 2 years ago, when there was I think that's what the first wave of COVID, after the first wave of COVID, when we got the vaccines, we actually had that system in Poland, which was responsible for 2 things. And that's a single system, right? One of them was when there was a nurse that was actually injecting you with the vaccine, right? They would check the patient data, basically, and mark that this patient got the vaccination. So, you can basically get that information in the system. And then the patients would register inside the same system, right? That makes a lot of sense, correct? Well, not really. If you look for the different quality attributes of those or the quality requirements. So there are a fixed number of nurses. There are not enough of them, actually. So that means there is a fixed request per second, right? And not too many of them. But there is a very high SLA because you got this long queues and people waiting them, and those vaccines taken out of the boxes and refrigerators, and they're going to get out of date if you're not being able to inject them. So basically, this requires a high service of level agreement. On the other hand, you get patients that won't try to register, right? And what happened when there was this? And how many do you have? Well, a lot of them. 20 in Poland, for example, that's in potentially 37 million people, right? But it's even worse than that. And what kind of SLA do you have to provide? Well, if I cannot register today, I will register tomorrow. So the SLA is basically 0, right? That's a very low SLA. So what happened when they opened up the registration for patients born after 1981, which is the year I was born in? Well, the script kiddies that we are born after, or before, actually, before 1981 and before, right? Well, we use the same tricks that we always use when we are trying to, win bids or on platforms and stuff like this. So we wrote some scripts, I suppose, because what we created is a distributed denial of service attack on that system, and it crashed. And what happens now is that nurses cannot inject those vaccines, right? So you have a big problem because the patients can create the denial of service attack, and the nurses, there are a fixed number of them, and the SLA is different on both sides. What would happen if these were two systems? If you have two systems, okay, now one system, patient registrator, will communicate with patient injector, whatever you call it. I have no good name for that. And that will, these will be two different systems. So then when the patient registrator breaks, you can still inject the patients because you have the information. You might not have more information about patients that are trying to register right now, but you got the old ones which are scheduled for today, and so you can continue. So here's the thing. Even if you're not building microservices, think about having different quality requirements like low SLA and dynamic and the traffic, or the another requirement, which is frequency of change. We'll talk about this in a moment. And try to split your system so that it's very easy to provide high SLA when you don't have to think about, a large traffic, okay? And it's okay to provide high traffic, high throughput when you don't have to think about SLA, but it gets worse or more important. In other industries, like for example, in aviation, we think in other ways than to duplicate something to make it work well, right? Because in our systems, when you want to have a better SLA, what you do is usually say, okay, I'm going to duplicate that service. I'm going to put it in two different instances on two different data centers, and that's going to solve the whole problem, right? But then, if both of those instances are attacked by denial of service attack, that's not going to help you much. Instead, what you should think now is that in a distributed system, when you have different microservices, modular microservices responsible for different processes, you can have different SLA per process, right? So that makes it much easier. And then you can think about, minimizing the failure impact. So if I have something when I expect a failure, how about moving this to a separate microservice so then when it crashes, it doesn't impact any other part of the system, right? And in innovation, what they do is they try not to duplicate stuff when they want to provide high SLA. What they instead try to do is they say, okay, the less moving parts we have, the easier it is to provide high SLA, right? So you will have the least number of engines possible on that aircraft so that, those engines can be checked over and over again and they do not burn like this one. Right? It's much easier than to over-provide the engines because they are heavy and also you burn a lot of fuel, so it's not economically viable, and also you will have more things to fix because, well, there is a failure rate for those engines, so they're going to fail, right? There's actually duplication, so it's not that bad. Usually planes can fly on a half of the engines, right? So, but that works for the aviation because engines do not change in flight. Nobody is trying to refactor them. Now, in the code part, that's a different story. In code, what we learn from papers like this one from Microsoft, a very good paper, The Influence of Organizational Structure on Software Quality and Empirical Case Study, is that the more changes you have to a piece of code, the more errors you have, because guess who introduces bugs to our code? Developers. We are guilty, right? So what happens is when you want to provide high SLA, make sure that you have low frequency of changes. If you can have low frequency of changes to that code, so you don't make too many changes, it will be stable sooner or later because you're going to smooth out all the errors, you're going to fix those errors, and then you can provide the high SLA. However, avoid as hell when you would have to have a high SLA and a high frequency of changes, because that's very dangerous. It's very difficult to do. And I would even say that well, maybe not impossible, because actually companies and teams work like this, but I'm not willing to work with something like that anymore because there is too much stress. And when I have a high frequency of change, but I don't need to provide high SLA, but I can have low SLA, that's very easy to do again, because, well, if it breaks, it breaks. We're going to start it up again, and low SLA, it's not going to impact on anything. So I try to split my services and my modules between different applications so that I can have the high frequency of change and low SLA, and high SLA but low frequency of change. Never have them both together. And when you look at the distributed systems, you have to look at different quality attributes, let's say, SLA, traffic, performance, or the frequency of changes, and try to mix and match them so it's easy to implement based just on that. So it makes sense to take one piece of the software, even if you're not doing microservices, move it and have two services now. So we're going to have a monolithic application and another part of the system, just so that when it crashes, it doesn't impact the rest, which has got this high SLA. And I'll provide the link to the paper in the slides. Any questions? What if the amount of the microservices is very low at the beginning, let's say 5 or 10 of them, and we don't expect high volume of events? Would you start with a distributed approach from the very beginning, or smaller steps, milestones? Okay, so the question is, can we build a monolithic application, modular monolithic application, and maybe later move to microservices when it pays off? There's a lot of things we have to consider. First of all, consider this. How many people do you have? If you have a single team, then it's very easy to actually implement the whole system as a monolithic modular application with one single team. However, when you have 1,000 people, then you're going to have bad time because, well, let me actually have a look. Sorry for that. Yeah, I don't have that book on this shelf. I have it on another shelf. There is a book from, I think, 80s called Mythical Man-Month, which shows that if you have 1,000 people working on a single code base, you're going to have horrible time, basically, right? So where is the point when it's not worth anymore to do monolithic applications, but instead to do microservices, because the communication patterns between different people and teams, the synchronization part, is going to be too troublesome? And the answer is, I don't know, it's up to you. For me, that will be 2 teams. If I have more than 2 teams, I'm not building a monolithic application again. That's it. But it also depends on the level of the people that I have. Because, for example, there is this Java master called Tomasz Nurkiewicz, which I used to work with. And this guy, if I had 40 guys like this, I could work with them building monolithic application. They are awesome, okay? But if I had like standard developers I can find this country, for example, then that means that I'm not going to build a monolithic application above 2 teams. And that's for me, because then the communication patterns, basically the communication, there'll be too much communication and people are going to get into each other's toes, and basically the cost is too high. And the next thing is you have to think in terms of, do I have the platform for all of this, right? Is my team, is my company already using Kubernetes on a public cloud with the Kafka provided by someone and databases provided as a service? If I have all these things already, right, then to be honest, for me, creating 5 or 10 more microservices or creating new microservices, 10 new microservices when I have all the platforms possible, no brainer. It's easy, right? Because I already know how to do it. So it costs me about 4.5 seconds to create a new microservice, including the template, the pipeline to production. Okay, everything. Well, I have to create the database again and put the password to the vault because I didn't automate that part. So apart from the database, right? So when I'm not being stopped, when I'm working with microservices, 5 or 10 of them, when building a new like piece of the software or new system, when I already have the whole thing, the whole ecosystem for the microservices, that's easy. But if you have one team and you're creating 10 services, and you're going to have to create, you want to support the Kubernetes, don't do it, then and Kafka and maybe learn observability, and then maybe on Azure you will use application insights for all of that. Oh, that's going to cost you a lot of effort instead of building a single monolithic application. So it depends on a lot of different parts. The number of people, first one, whether your business actually accepts the big risk of deployment, because if they do not, you cannot build a monolithic application, and whether you have the whole ecosystem for everything else. That's how I would reason about that. And it's okay to build it with milestones. So basically start with modular microservice, modular monolithic system, and then split it into microservices. I have seen success stories with that. Okay, so no more questions. Let's move on. Next thing we have is eventual consistency. And basically you have to read how to provide this. It's not difficult, really, but you have to do it. Even in event-driven system, when using Kafka, you have to learn that when you're sending an event to Kafka, you don't have a transaction for that. And the transactions in Kafka mean something a little bit different. So basically, I got a link for you if you are interested in Kafka about how to provide this kind of eventual strong consistency or eventual, how do they say it? They don't call it eventual consistency, but eventually, I'll let you read the article, but to make sure that the event is processed actually at exactly once on the other side, and it's eventually once, not exactly once, right? And two things you have to learn, and I wish I learned back then in the days, is the transaction outbox pattern. Very simple thing to do, very easy thing to do, helps a lot. And basically, whenever you are sending events, use that. And then when you're using a message bus, basically, you have to understand the guarantees that Kafka provides and what does it mean for you. So basically, okay, so what if my database breaks? Oh, I have an option there. I can either move and commit the offset or basically not move the offset, but I will stop processing at that point. These are business decisions or process decisions that you have to make based on the technology one. You have to learn that technology, okay? But eventual consistency is not as hard as I thought it would be. Okay, so now we move to event-driven distributed systems and their problems. And for me, event-driven, well, everybody knows the benefits of that, or there's a lot of talks, very good talks about the benefits. So I'm going to talk on about the problems. First, the problem is that if you want to have event-driven distributed system, so microservices talking through, for example, Kafka, somebody has got to do a PhD on the message bus because those message buses are not that simple. And I prefer Kafka because you can actually easily do the PhD on that. If you decide to use something closed source, the problem is right now you think you're doing the PhD on that message bus, but in fact you're doing the PhD on the marketing information of that message bus. And that can be incorrect. So if you think that people who write in documentation, they never lie, well, that depends on the company. But sometimes those companies have got those people who work in marketing and they will lie to you. So don't trust them, okay? You have to be very careful. So anyway, you will have somebody doing this PhD, or you will sooner or later find out you have to do it, because without a PhD on that topic, you will not be able to provide support for it. Now, there is a problem that people create a lot of chaos because they do not understand two popular things that I found out in practice. The first one is there are events which are public, which means they go between different teams. So you have a topic, everybody can read from that topic, but you have to support, the versioning of that information, basically propagation of that information and so on. There are topics which are only being used within a single team. And when I have events that go between different services of my team, what happens is I control the producer and all the consumers. I'm aware of all the consumers. So I can do a lot more at that case, because I can say, oh, you know what? Let's do the antithesis of microservices. For this single time, we are going to put this whole system down, basically change and deploy in new versions, when we are going to talk on a completely different topic on a completely different way. And even though it's the antithesis of microservices, who cares? It's going to work because I control both the producer and all the consumers. Now, the public topics where you don't know who's consuming those events, you can't do it. You will break the consumers. Never do that. And there is the private events. Private meaning that I'm sending an event to Kafka and the same microservice receives that event, right? Why would you do it? First of all, you can use Kafka as a kind of a storage for type of communication like with event sourcing, right? And then you have to think in terms of, okay, I can use Kafka, for example, and partitioning in Kafka to distribute the workload over different threads, right? So I can, for example, have some threads which are very slow because they work for that party and they will consume those events slower, but that's okay because they will catch up in the night. And I can have those threads working on much faster on better consumers when I have different parties and they are much faster than that one, right? So you can have this kind of private events and it makes sense, and you use the Kafka as a kind of a storage or distribution pattern for different threads. And then you are very close to what Akka provides, right? So it's basically the same approaches because this is all reactive systems, I think. Okay, then the next problem is, and what happens when you don't understand this? A team will steal my private event. And so it's the public event from now on. And that's a huge problem because I cannot refactor those topics anymore. And my code, well, you understand what's going on. Now, the next thing is that event-driven architecture, event sourcing, and event storming all use the word event, but they are different things. So what are they, right? Event in event-driven architecture, it's about communication pattern. I'm talking to you, my module to your module, or maybe those two microservices, and this is how we communicate, right? Cool. Now, event sourcing means I now persist those things. So this is a persistence pattern. I can rebuild from the bottom. So basically, I can prove, for example, how do I get those number of money on my bank account, right? Based on all the events that happened. It provides a lot of different benefits, but the important thing, it doesn't have to be your communication pattern. You don't have to send all these things that you store into the database to the message bus. And the other way around as well. And then you got event storming. Oh, I wrote that wrong. And event storming is an analytical way of basically modeling processes. So that's a business event that you have in event storming, right? Which means something that happens in the business. It doesn't mean that you have to have communication like that, or that even you have to store something, information about that business event in your system, because, well, we are about the technical details. The programming is the master of technical details. And the event in event storming is something that happened in the business. It may or may not become some kind of an event in your technical system, okay? Sometimes they look identical. They don't have to. That's the important thing. And the event word is here not abused, but like confused a lot. Any questions? What to do when we have a read model formed through events coming from multiple microservices and one of them crashes? Isn't the read model now distorted, making the module relying on the read model defective? Well, that depends how you model this. So this would be very difficult to show in a general way because we can focus on something. So for example, let's say the car was rented and the car was returned, right? Let's go to that, back to that. So what happens when you have car was rented, car was returned, so something like this, right? And car return breaks, okay? So nearest car locator needs both that information because it's trying to reason about whether I have up-to-date information about the car. Is it available? Is it not available, right? What happens when the car return breaks? Well, nearest car locator searches for the cars that are available. So it will not know that it was returned. Okay, so it still assumes that the car was rented. Is it a problem? Well, we won't be able to return this to search for this car, basically inform the user, you know, this is the car nearby which is available. But apart from that, the whole system will work, right? Nothing wrong will happen in the system, apart that maybe you're not earning as much money as you would like to. What happens if the car rental doesn't work, right? So a user tries to rent a car, it can't rent the car, so we don't have information about car was rented, so the car is still available. Yes, it is. So we still return that information to the nearest car locator, by the nearest car locator to the user, right? And we say, yeah, there's a car nearby. Okay, but the user, when they come over to that car, they won't be able to rent that car because car rental doesn't work, right? Well, what can you do? Nothing. Still, the information, the read model on the nearest car locator is correct. This is all I know, right? I don't know that the car was rented because, well, car rental doesn't work, right? Or maybe even worse, car rental actually worked, but it didn't send the event. The part that sends the event doesn't work, right? So we will send the user here again and again, and even though the car actually is rented. So the user will actually be have a problem with that car, right? So from that perspective, now we have a distorted read model, which means that our read model is not correct. But here's the thing. If these are distributed systems, these are different applications, the data is always inconsistent. There is never such a thing as consistent read model. The read model is always out of date compared to the source because of the speed of light and the fact that these are two different machines in a physical world. Okay, so when I'm sending car was rented, okay, I can already change that state in can rental, and at that second, the nearest car locator will think that the car was rented, but it's not true anymore. You cannot protect against that, and it's okay. It turns out that it's not necessary usually. Like you don't have to have those strong consistency here, and if you do, then you have to. And usually, when you do, you have to do this because you want to provide invariants. And that's how you protect the state, putting it in a single microservice. So, in other words, nothing happens when car rental crashes. Who cares? Nearest car locator team doesn't care. The user might care a little bit, right? If they come over to that car, but what can you do? You have to live with that stuff. And basically, when it gets up and sends those events, because, for example, you have the transactional outbox pattern there, or any outbox pattern, then that means we will have the up-to-date information, or maybe not up-to-date, but we will have the eventual consistency of knowing that information, right? You have to accept we never have up-to-date information because speed of light. More questions?
Two more, right? Yeah.
Where should I put read model that contains data from different microservices? Is it new microservice? Is it new microservice? What in situation when read model is fulfilled by events also from microservices from other team? Who is responsible for that read model? So here's the thing. Where should I put a read model that contains data from different microservices? The answer is you will have that read model whenever you need it. Okay, so every single microservice that needs that information will have its own read model of the same data. Okay, so read models are not shared between microservices. I have my own read model, that microservice has got its own read model. We have different read models because we are interested in different sets of data, even though we are fed and build those read models based on those same events. Who is responsible for those read models? I am responsible for building my own read model, but the other team who sends the events that I'm based on is responsible for their events, right? So what that means is that events on the topic are incorrect, wrong. Somebody is sending me events and they are wrong. That team is responsible. If I create my read model and I have an error in my code, in my Kafka streams, for example, or maybe in my read model built locally, then what happens is that I'm responsible for fixing that, right? So they're building the read model. That's my job for my microservice. On another microservice, that's the job of the team responsible for that another microservice. That's it. There is no global read model for everyone.
Okay, two more.
In modular monoliths, do you have any tests that cover the whole app? Yes. Not a single module. I mean, if a user registers, we want to know that he can log in later on, know that some events was emitted. Okay, I get you. So I try to keep my integration test, unit tests are, my unit in unit testing is a module. Okay, and I use behavior-driven development to test that. So I'm not looking inside the module. I'm only testing the behavior of that module. My integration tests are also about modules. I'm not testing in integration test. I rarely do kind of a test in a modular monolith when I test the whole thing. I try to do it. Why is it so important for me? Because for me, every single module is a candidate for microservice. If I want to rip it out and move it out, it's going to be much easier when it's got its own set of tests. But then you have those, communication between different modules. And in a modular monolith, all you need actually is a strong typing language, right? So you got Kotlin here, Java there, I get Groovy strongly typed, and the compiler checks whether you will be able to communicate, right? So do you need an end-to-end test? Well, in a monolithic applications, sometimes you do, but there are different types of tests. So, for example, I only have stress tests like this. Right now, I don't have in modular, but here's the trick. I'm programming microservices for like 7 years now, right? there are modular microservices, and my microservices sometimes have up to 5 modules, but that's not a large amount of modules for a single application. If I were building a large monolithic application, like with 200 people like I used to, if I had to do this and build hundreds of modules, right, then I think it would be even more important to have tests per module and no end-to-end test per the whole flow. Although having a test per the whole flow is possible in monolithic application and sometimes is required due to, for example, how safe you want to be, right? Because, for example, people will die if that application breaks. So monolithic applications are quite often do not have to be resilient. It's actually very difficult to provide resiliency in a monolithic application. It's much easier to do it in a microservice-based system because you're only thinking about resiliency of several different paths, and you don't have to have all, everything resilient, just the critical paths, right? So I don't do that, but last 7 years I worked only on microservices up to like 5 modules, so no big monoliths. I actually move big monoliths to the cloud by strangler pattern and creating microservices on top of them.
Okay, next one.
How would you approach splitting work from one big event into multiple small events? What if your process breaks during splitting? When half of small events are already published? Ooh, that's bad, right? So I'm not sure what that means because I'm like from a business perspective, what it means to split work from one big event to several small events. But I can imagine you can have that situation. I usually have the other situation when I have several small events and I'm trying to reason and build a read model or create an event based on that. But if I had this, what to do when the process breaks during splitting? Very easy answer. Use transactional outbox pattern. So basically, you never send any more events to anyone. Like you are just saying, oh, this is the large event. I'm going to split it into several small events. I'm going to save them into the outbox. I'm not sending it to anyone. Instead, I'm going to commit the transaction when it's all okay. And if it's not okay, if I break in the middle, that means I will roll back, right? So nobody will get that messages. And then you have another thread which reads from the outbox and basically sends them one by one. And you're all set.
Okay, and next question from Greg again.
Okay, there are times when varying read models have such high overlap, duplication, that it is worth having a canonical model, no? What would be the criteria to look for on this? That's a very interesting question. I remember when Martin Fowler wrote that the canonical data model never worked for him, and that was a huge topic back in the service-oriented architectural days. And I remember, but it was wrong for so many reasons back in those days when all those companies tried to use the enterprise service bus and actually couldn't communicate with each other too much, and that the logic was in the enterprise service bus. So we moved to microservices, stupid pipes, smart endpoints, right? Something like that. But what happens when you have so many read models when they overlap? Well, is that a problem? Like, for me, I haven't seen a problem with this. I have several read models. Like, I actually didn't prepare, and I'm sorry for that, the architecture diagram of my microservices that I work on in my system. And I had that prepared, but I haven't actually, the security didn't allow me yet. I'm still waiting for acceptance from the security to be able to show it on presentations. So I didn't get that agreement yet to be able to show it. But what happens is that I have like maybe 20 different read models on my microservices. I got 60 microservices in production for one team only in a large system, and they have 20 different read models. And there is one event that is being split, or actually I have the splitting situation, when I'm actually sending 4 different events based on this event, right, to create different read models, and they overlap. In fact, most of those events are exactly the same. And the reason why I split them and I send them to different topics is because I partition that in a different way on Kafka. So Kafka has got this partition keys, and I want to be able to process that information either looking from the perspective of a location when the station is installed, or from a station and I don't care about the location. So there is a different partition key. And so I sent several events. Some of them are identical. Others are like, okay, I changed a little bit. So I'm changing the format. For example, I'm representing a station and I'm changing the format of the station from the internal that we have in domain in our company, whatever we call it. It's not a canonical model. It's just, just how one of the service communicates about stations. And then I'm changing it to another format, which is the OCPI format, which is the protocol to communicate between different businesses about charging cars, and basically the way that you can charge your car on any station in the world, maybe not in the world, but basically in Europe, let's say, instead of actually not being able to charge on a different station just because you have an agreement with one company. And so I changed the format of that event to OCPI protocol format event, just so it's easier for some of my consumers to be able to build read models on top of them. And the overlap is huge. Like, this is exactly the same data, except it's built in it's formatted in a completely different way. Okay? Do I have a problem with that? Turns out, usually no. Well, I have those overlaps, but a single microservice would either use this read model or that read model, never both of them when the information overlaps, right? I never had that situation. Maybe that would be a problem if I had two different events from two different sources and the information overlap would kill me, because you have to have a single point of truth from my perspective. So I wouldn't know whom to trust. But I don't have that in production. What I do have in production is when you have an error in your own code, then I have a situation when I'm sending those 4 different events based on the single source event, and they all have different errors, and that's problematic. Or what if I've made an error in the OCPI protocol? So basically, I'm sending the information about station to one microservice or to a Kafka topic, but basically there's a bug there, and there's some kind of field is completely wrong. The other read models are fine. This one is not, right? So again, we fix this, we send a baseline, we inform everyone else, and if in case there is the independency of different microservices, we have to manually clean the database, basically, and send that events again. So that's manual work. We try to avoid that as much as we can.
Can I follow up with Greg?
You keep mentioning service read models. What about reporting read models, which also exist, often listening to events from many services? Oh, yes, definitely. So reporting read models, well, we usually report to people, right? Because you can think about it, or the way we think about it is, okay, if I want to have analytical information later on for processing, that would be push that information to the data lake. So feed the data lake, it will get processed with Spark or whatever else later on. But if I want to show reports, so that basically that's a UI, for example, that shows the customer or the customer service, let's say, the situation. Oh, so what's the situation with this charger, right? Or what's the situation with charging this car? Because, you know, the customer calls us and they say they're not happy because they cannot put out, take the plug basically out of the car because it's locked. And then the machine does something stupid. So basically this kind of things. So reporting read models for reporting when people are actually looking on it, and we not make decisions on top of reporting read models. I think the main difference is this. We have read models when we base our actions on, in terms of we have software that runs based on those read models, right? That is like a service read model. Now, reporting read model would be something for the human eye, for me. And that's a completely different story because, well, for the human eye, we tend to collect a lot of different information on services. The UI is complex. You get information from the different sources and you try to represent this. Is there a problem with this? Well, of course there is. First of all, we are limited by the speed of light. Second of all, it's not that easy to actually handle because, well, your UI basically, or the backend for frontend, wherever you have the microservice that serves the frontend there, has got to understand all those events, right? So what do we do? Well, I have no answer to that. We just try to cope with this. You can, what I would suggest is that if you have reporting and it's very difficult and complex, maybe what we should do is create this kind of a pattern, front-end pattern, which is called, I think, composite UI, where each microservice, which has got some information and sends events, could also provide information for the like customer service, for example, by providing a part of the UI. We could do that, and then it would be much easier because the reporting read model doesn't have to reason about what it's reporting, right? You can have that information directly from the microservice. The only problem with this approach is that microservices who are event-driven right now, they're only consuming events and sending events, right now would also have to handle REST-based calls from the front end, right? Or something synchronous. And that might be a problem because, first of all, the SLA, we are not going to be able to restart the microservice whenever we want, right? So the SLA will go higher. And, well, that's another protocol to add to the microservice. It makes it more complex. So I would have to think about it this way. I used to have services that would provide both UI and events, and it wasn't that bad, but I think it's a case-by-case basis.
And last one.
How to handle situation when you need confirmation synchronously. You register device, IoT to system registration is one service, okay? And next, you redirect to the to device details, second service, but event wasn't propagated, so user will see 404 page, right? So when you have asynchronous communication, what you have is you don't know when that will happen. So what can we do about it? Well, there are two options here. Either you make the first system when you got that event from, so for example, registration of device, somebody registers that device. You make them wait by providing synchronous communication. So basically, I'm not going to send an event. I'm going to change the protocol. Here, I'm going to call the REST endpoint, and I'm going to block my thread till I get an answer from that, okay? That's what's happening is you're making the user wait, right? Or the external system that is calling registration, wait till you finish. Because if you have a REST communication there, at least you will be able to, postpone the answering to that question until you have an answer or there is a timeout. Now, that's one thing. The other thing is, okay, you have to accept that the communication may not happen yet, when you're sending that information to, when you're directing to device details. So what do you do when there is a 404? Nothing. You just change your front end so that, or the consumer of that information, so whoever was redirected to the device details, right, page or endpoint, you get them, and basically what you do is you retry. You do what's called, I think, probing. I don't know when that information will be reached here and when I will be able to see it. But I will try every now and then until I actually get it, right? So one way to do it with REST communication, because you're talking about 404, which means usually that you have HTTP there, right, is probing, sending the request over and over again with some timeout, right? So that's one thing, but that is going to create a lot of traffic. So maybe what you could do is you could basically ask, like, open a connection there, use a WebSocket or RSocket. Basically, open a connection there and say, you know what? Give me these details when you have it. And then you will have just one HTTP request there, and then you will get back the information when it's ready, assuming it will be ready in time that you can spend waiting for it. So two options. Either you retry on read, so basically that's probing, or you block the one service or the thread that is trying to register the IoT. Okay, so having that, there are three more problems with event-driven systems that I forgot about. First one is that there is a hidden cost of serialization deserialization. So what happens? If your microservice tries to read a topic where there's a lot of events and it's only interested in 10% of them in a very specific event, like car was returned, and there's a topic where there are all the events about the car. From a perspective of a developer, what you do is, oh, wait, yeah, but we just skip those events. We don't care about them, right? And we are just waiting for the event that will actually be the car rented or car returned, and that's the one we are interested in, right? So the developers do not see this, but what happens is that you receive all those events. There'll be thousands and hundreds of them, and you sometimes even deserialize those events only to decide that you're not going to do anything with them because they are not the type that you expected, right? That's a hidden cost. You can have a large volume of traffic there when you receive a lot of events that you don't do anything with them. When you have this kind of a situation, remember that you can always split a topic into smaller ones. So basically split it to streams of specific events. And it's better if all the events that I receive on the topic are the events that I'm interested in, right? Try not to have topics that 90% of the events I'm not interested, right? This is a huge waste of, in this country, coal, but in Europe, basically energy, right? Don't do it. Now, the next thing is you have to learn to partition data to achieve performance, right? If you think you can get away with optimistic or pessimistic locking, then I have bad news for you. When you're trying when you are processing events, that can get quite fast, okay? That's really working really fast. So if so far you were working on optimistic or pessimistic locking on a database and you want to be very performant, stop and instead think about, read and learn about partitioning of data. If you're using Kafka, you got those partitions, you need partition key, and basically you need to be aware of that. And it's going to be very easy to just do the work without any optimistic or pessimistic locking whatsoever, okay? Sometimes. Now, and the next thing is, make sure that you're not dropping any events. That's the worst case scenario for you, because if you have a microservice and it just, sometimes it doesn't receive some events, why does it happen? Don't skip that. Think about it. To make sure that it works, you have to have at least a transactional outbox pattern. So basically any kind of an outbox pattern when you ensure that the event gets there, and at least have a dead letter queue, which means that if I receive an event, I can't process it because there is an error there, the serialization is wrong, whatever. Send it to a dead letter queue. So at least you will know exactly which events you had problem with. And it's going to be very easy later on to say, oh, I'm going to take them. I fixed the bug. I'm going to take them and send it over to my application again, because, I know exactly which events didn't pass. That's important. So whenever you are consuming events from Kafka topic, use a dead letter queue by default. Whenever you are sending events to a Kafka topic, use a transactional outbox pattern or any kind of outbox pattern to be able to make sure that it gets there. Otherwise, you're going to have a situation like I used to have, where you have several different services there and not all the events got propagated. And that's a horrible scenario because you don't even know which ones were not read or didn't arrive, right? Okay. So orchestration and choreography, maybe it's getting late, I think. Yeah. So maybe let's not go into that one. All I'm going to say is there are two things you have to read. The first one is the data mesh, the answer to new data warehouse hypocrisy, which explains exactly why you cannot have orchestration in your distributed systems and why you should prefer choreography. And there is also David Schmidt's talk about it from DevOps, by the way. And the main reason is if you're working with several teams, orchestration means one team has got to understand what's going on in other teams and what's going on with my events or basically with whatever I send. And in choreography, what it means is I don't have to reason about other teams and what they do, and I can focus on my product and my microservice. And it's much easier to achieve. And basically, that's the gist of it. Okay, so so many things here. I'm going to leave you with a list of good books that I found and then move to the last questions. The first one is Software Architecture for Developers, a very basic book, but I think this would be basic for all the architectures out there, so all developers should read it as a kind of a part of being prepared for the job of architect as soon as they can. I think this should be in the university. The next thing is Fundamentals of Software Architecture and Engineering Approach. That's a very nice book, very similar to Software Architecture for Developers, although completely different in terms of the focus, right? But also this is a basic book that you should read just to, be able to talk with architects and think about architects, and it will structurize and help you think in how do we deal with architecture, right? Then there is this book, Software Architecture, the Hard Parts, Modern Trade-offs Analysis for Distributed Architectures. Very interesting. This is a fresh book. I think it's got 1 or 2 months old. And it talks about difficult parts. I don't agree with all of it, but as I said, I'm not sending you like a silver bullet or a silver hammer to solve our problems. It only works for me because that's the topic of the talk. So things I would love to learn before. But it's a very interesting book nonetheless. I suggest you read it. A very good book on event-driven systems by Ben Stopford. This one is for free because Ben Stopford works for Confluent, authors of Kafka. So there is a lot of marketing on Kafka in this book, but it's a very good book. Even if you don't use Kafka, it's worth reading it because it explains the read models and processing, stream processing, all those things and patterns. There is a reactive design patterns book, which will not teach you about reactive programming perhaps, but will explain the idea behind things like akka and behind things like what does it mean to have an event-based reactive system out there, right? There is another book called Team Topologies, which is that one which will explain to you there are teams which will focus on tooling only, and there are teams which need to prepare software as service, and there are the teams that provide the business value. And you have to split it somehow and think about when you are redesigning the whole setup of all the teams in the system, that's the book you should read, right? And of course, the old golden domain-driven design, tactic, complexity, heart of software. Just remember that the last, I think, half of the book, the second half of the book is communication patterns between different mode and context. This book was written 20 years ago. So some of those patterns we know better now, okay? So the second half is not up to date, I would say, but the first half is completely fine, okay? All right, good luck. So what are the last questions?
Yeah, the last one just show up 2 seconds ago, so I will show to you.
If we start using domain-driven design aggregates and read models, do we need relational databases? I think relational databases are a big problem for all the Java developers, object-oriented programming languages developers, and functional developers. The relational model, I love it. Like most of my life, I actually spent developing relational databases. I love the model. But as a programmer of object-oriented languages, it's a horrible thing, and the domain-driven design aggregates and read models are a much better approach to how you access the data, how you store the data, or maybe even going to event sourcing. But the relational databases are horrible because if you think about it, DDD aggregate or anything you have in Java is a tree structure, right? You cannot have any kind of other, well, you can have cycles, but you usually have aggregates are tree structure. You got the aggregate root, and then you have objects underneath, and you cannot interact with those objects except from the top to the bottom, so from the root. That's what aggregates roots are for. Relational database is a bidirectional, unidirectional mesh, right? So it's actually, formally speaking, it's unidirectional graph. You can create a query from each end of the constraints that you have and tables, and it doesn't matter how you're going to ask the query. That's very elastic. That's very flexible in terms of asking questions. But that's a horrible thing to do when you have to work with this in object-oriented languages where everything is a tree, actually. Okay, so it's a horrible situation to be in. So that's why I use PostgreSQL as my daily database usually if I cannot have MongoDB. But when I use PostgreSQL, I try to use the object-oriented format of it. So that's JAX-B, basically, right? The fields of type JSON-B, not JAX-B, JSON-B, right? So I store JSONs as fields in my relational database, and Postgres supports that, allows you to query for this, and allows you to create indexes. There's not everything I can do with it. It's not as flexible as, for example, MongoDB, but it gets the job done in a lot of things, okay? So I would say you don't need relational databases ever. Maybe not ever. I'm correct, but like most of the time, you don't need them, right? They have very good approach to transactions, though, right? Like really large transactions. The support on relational database is great for this.
Okay, thank you very much. We don't have any more questions, but if you have some, just shoot it, because we thought it would be 60-minute talk and 30 minutes Q&A, but we have like 2 hours and 20 minutes. So probably the longest presentation of Kuba.
Oh, God damn it. Sorry for all of that. And thank you for staying with me. This is incredible. Like I'm used to talking too much, but like, wow, this time I really like talked way too much. Sorry for this.
No, I mean, thank you, Kuba, for your time. There's nothing to be sorry about. Thanks for sharing, and thanks for staying with us so long and answer all the questions, even from Greg Young. So
thank you, Greg. Thank you, Greg. I think looking at your questions, I think you are way higher than I am. I'm like a way lower in terms of the abstraction level. I think in terms of what I have experience with, what I've done, but your way, you're thinking you see much more than I do. And so that's where your questions come from, and I cannot answer most likely them at all.
We need to organize a session with Greg Young for sure. So Greg, if you are still there, let me know if you're okay, and we can do a Q&A with you as well. Okay, I don't see any more questions.
The link to the presentation. I'm actually going to pass this on chat. And maybe you can pass it on the Google, whatever we have there as well, right? So
yeah, if you can pass it here, I'll grab it from the archive.
There you go.
Whenever we'll be publishing on the YouTube, we'll send a link, post a link there as well. And whenever I'll be sending email to all the DevFlix users, I'll send it as well. So
thank you.
Oh, there is one more. Greg said, why not? So one more session for the DevFlix in the future. Okay, thank you very much, and have a great rest of the day, night,
evening,
whatever. See you. Bye, guys.
Bye-bye.